Okay, so we've talked about how to tell certain things about an exponential equation by looking at the graph. And now we're going to try to find the exact equation by looking at a table of values. So all of these equations are going to be in the form y equals a times b to the x. Remember, we call this b the base. And you'll notice here that there is no plus c on the end. So what that means is when we do these type of problems, we are not going to deal with any that have a added constant. So that means that it will always flatten out at y equals 0, because remember that plus c number tells you where on the graph it flattens out. If there's no number written there, it's 0. So these are all exponential equations that flatten out at y equals 0, which is along the x-axis. So we're not talking about any that have been moved up or down from there. But other than that, we could have a positive or a negative number for a, which would cause it to either have a steep slope in the upward direction or the downward direction. And we could have a number for b that is either greater than 1, meaning it will be steep on the right side, or less than 1, meaning it will be steep on the left side of the graph. Okay, so the first couple examples here are not too bad, because if you look at the table, we have x values that are increasing by 1, and we have a few of these to look at. So it'll be pretty easy for us to tell what the pattern is here. So x goes -1 to 0 to 1 to 2 to 3. These are increasing by 1. They're counting up by 1. And these y values, let's try to figure out what we are doing as we move from left to right. 3 to 6, maybe it's plus 3, but then 6 to 12 is not plus 3. So it's not that. How else could I get from 3 to 6? Well, I could multiply by 2. So is it multiplied by 2? And then 6 times 2, yep, would be 12. 12 times 2 would be 24. 24 times 2 would be 48. So as I'm going from each x value, I'm adding 1. As I move along the table for the y values, each one is being multiplied by 2. And this number that we are multiplying by every time is the base. So that means that b equals 2. To find a, if we have a nice table like this that includes 0, it's pretty easy. All we need to do is look and see which y value goes with 0. And this number will be b, or will be a. This is not true if we had a plus c, right? The y-intercept depends on both c and a when we're looking at the graph. But when we don't have a plus c, then this number a is just the y-intercept, which is the number that goes with x equals 0. So this means a equals 6. So I'm going to take these two facts and I'm going to write them in this form. I'm going to write y equals a times b to the x, but in this case a is 6 and b is 2. And if I wanted to, I could check this on a graphing calculator by putting in this equation into the y equals, the one that I just found. 6 times 2 to the x. And then I want my table to start at -1. There we go. We can see that these numbers do match the numbers that I was given. So it's pretty easy to check your answers on a graphing calculator, but it's not so easy to just find this answer on the graphing calculator because you need to know what the equation is to put it in. Okay, let's check out another example. Rewind if you need to. What do you think A will be? How do we know where to find A in this table? Okay, so A is whichever number goes with x equals 0. So in this case, A equals -4. Okay, and then for B, we're looking for the pattern in the y values. And when it's an exponential equation, we're always going to be multiplying by the same number each time, which means that we're looking for what number do we need to multiply to move to the right in the table. What number would we need to multiply -4 by to get -20? That number is going to be the B. You can pick any two of the y values to kind of investigate. It's probably the easiest one to do what number do I need to multiply between these two, but any two of these would work. So yeah, it is times 5. And let's make sure this pattern holds. So -20 times 5 would be -100. And then let's make it sure it would also work this way. If I took -4 over 5 and I multiplied by 5, those 5s would cancel out. And I would just get -4. So I could indeed get from this number to this number by multiplying by 5. Same thing here. If I multiplied this fraction by 5, 25 on the bottom, and then I'm multiplying by 5, I could take this 25 and turn it into 5 times 5, and then some of those 5s would cancel. So I could get from here to here. So each time I'm moving to the right, I'm multiplying by 5. Okay, so that means that B equals 5. So then what would the equation be? It would be y equals A, which is -4, times B, which is 5, to the x. There we go. No problem. A can be a negative number. B should not be a negative number, but it can be a fraction. And if it's a fraction that is, or a decimal, less than 1, that means that it's going to be steep on the left side of the graph and not on the right side, which would mean that we get the big numbers on the negative x side. Both of these have the big numbers on the positive x side. Exponential equations tend to get really big numbers really quickly. That's kind of the property that they have. When you look at the graph, you see that it gets very steep. That means that we get these really big numbers. Okay, let's look at this next one. And this has a slight difference between the first two examples. And that's because if you look at these x values, they are not increasing by 1. They're increasing by 2. So really, we can't necessarily use the exact same method because we're missing some of the information. So if you think about it, we could make a new table where we fill in those missing values. I know that 0 should have 2. I know that 2 should have 18. I know that 4 should have 162. I don't have these y values that go with x equals 1 or x equals 3. I'm missing these. But I still want to be able to find what number I would need to multiply by each time in order to get these results. I can still read off the a from the table because I do have 0. So I do know that a equals 2. But for the b, it's going to be a little more work. So I'm going to explain this in a couple of ways. The first way, we're just going to try to figure out what number we would need to multiply by each time, even though we don't know this middle number. So between 2 and 18, I want to multiply by the same number twice to go from here and then to this next spot. So there's a few ways you could think about it. You could just try some different numbers. So I could do 2 times 2 is 4, times 2 again is 8. Nope, we're looking for 18, right? 2 times 3 is 6, times 3 again is 18. So if I take 2 and I multiply it by 3, and then I multiply that number by 3, I do get 18. And this missing number here was 6. Let's make sure that this pattern holds. If I take 18 and I multiply it by 3, I get 54, okay. And then if I multiply that by 3, I get 162. So if I take 18 and I multiply it by 3, and I multiply it by 3 again, I get 162, and this middle number was 54. So you can just kind of experiment, but it won't always be as easy to find. Let's also think about how we could do this more methodically. If we're looking at 2 and 18, from 2 to get to 18, overall, we need to multiply by, well, maybe you know, but if you don't, we can divide them, right? 18 divided by 2 is 9. So think about this. We divided those two y values, 18 divided by 2. We found 9. That means that to get from 2 to 18, we need to multiply by 9. But based on our table here, we needed to break multiplying by 9 into 2 steps. So instead of multiplying by 9, we really kind of want to multiply by 3 and then by 3 again. So what relationship does 3 have to 9? We could multiply by 9. That's the same as multiplying by 3 times 3. And that's because 3 is the square root of 9. So instead of just experimenting with numbers here, what we could do is divide these two to find 9, and then realize we need to break this multiplying by 9 into 2 steps of multiplying. So then instead of multiplying by 9, I'm going to take the square root, that gives me 3, and then I'm going to multiply by 3 and then by 3 again. That's the same as multiplying by 9. Okay. Either way, I found that A is 2 and B is 3. So that means my equation is 2 times 3 to the x. Okay, let's do another one. So here we are missing more numbers. I'm missing 1 and I'm missing 2. So if you want, we can start by doing kind of the same thing we did here. Try to figure out what number I need to multiply by to get from 2 to 16 in 3 steps, because I need to do times something here to get from this spot to this spot. I need to do times something here, and I need to do times something here. These are multiplications, not x's. I need to multiply by the same number each time to get from here to here. And maybe you can tell that that number should be 2. So 2 times 2 would be 4, times 2 would be 8, times 2 would be 16. So I can multiply by 2 to get 4, by 2 again to get 8, by 2 again to get 16. This works. I multiply by the same number each time for each step. So that works okay. But let's try to see if we can think about it in a way that we didn't have to guess and check. So we've got 2 and 16. To get from 2 to 16, what do I need to multiply by? Well, you can divide the 2 to figure that out. I need to multiply by 8. And I need to break multiplying by 8 into 3 steps. So I want to know, how can I multiply by 8 overall, but in 3 steps of the same number? And the answer to that is the answer to the question, what number times itself 3 times gives me 8? That's the cube root of 8. Cube root of 8 equals 2. So that would also give me the 2. So I divide the 2 y values, and then I need to take the root according to how many steps are in between those 2. All right. So the equation here would be y equals a is the number with 0, so it's 2, times b is 2, because that's the number I multiplied by, to the x. There we go. Okay. This next question, example 5, is really similar to this one, just given in a different form, where we're given 2 points, and we need to figure out what the a is and what the b is. This time they're not written out in a table like they were over here. They're just given to us in terms of the x and the y. So here's what we'll think about. How many steps are we taking to get from 0 to 4? 0 to 4, 0, 1, 2, 3, 4. 4 steps. And to get from 5 to 405, what do I need to multiply by? This one, it's not a math fact you have memorized. You don't know it off the top of your head, but we can just divide 405 divided by 5 is 81. So I need to multiply by 81 to get from 5 to 405. That means that I need to multiply by 81 in 4 steps, which means I'm going to take the 4th root of 81. Maybe you know this one. It's kind of on the list of common exponents, but in the graphing calculator, you can type math, and then it's this number 5. You want to type the root first. So 4th root of 81 is 3. My calculator is a little older than the ones in school, so it looks a little different when you type it in. In school, I think it's actually a little easier, but 4th root of 81 is 3. Most scientific calculators will have a way to do this as well. So look for something that looks like a little square root with a little x next to it. That's probably the way to do something like a 4th root. Or you can probably try typing it into Google and that'll probably work also. 4th root of 81 is 3. This number is our b. And our a must be 5 because that's the number with 0. So we have y equals 5 times 3 to the x. If we want to check this, we can type this equation into the y equals 5 times 3 to the x. And we're not going to have all the points, but we can make sure that we have these 2 points. So I have 0 and 5, and I have 4 and 405. So I found the right equation. All right. This is not the only way to do this. This is kind of an informal way based on what we did in the table, but I'm going to show you the more, I guess the more algebra way to do it, but it's going to end up being the same thing that we did here, just in a more algebra step kind of way. I don't care which way you want to do it. You could write the whole table out and figure those numbers out yourself. That would be one way. This is another way, figuring out how many steps, what's the number that gets multiplied, and then doing the number of steps root of that number to get the b. That works perfectly well. Or we can set up a system of equations. So I know that I want y to equal a times b to the x, and I have 2 sets of numbers giving me x and y. So I'm going to put in these numbers for x and y, and I'm going to put in these numbers for x and y. So here I have 5 equals a, I don't know a yet, times b, which I don't know, to the x that goes with this is 0. So I know that anything to the 0 is 1, so even though I don't know b, I know that this equals 1, which means I'm just multiplying a by 1. So this gives me a equals 5. Now this equation, y is 405 equals a times b, which I don't know yet, to the x here is 4. Okay, so what I did is I put in the x and the y of these 2 points into y equals a times b to the x. From this first equation, I can figure out that a equals 5, and then I'm going to put that number in for a here. So now I have 405 equals 5 times b to the 4th. I can divide both sides by 5. Oh look, we're dividing 405 by 5 just like we did over here. So that's 81 equals b to the 4th. Now, to get b by itself, I need to get rid of this 4 in the exponent. The way that I do that is the 4th root. So I get b equals the 4th root of 81, which equals 3. So if you look at these steps versus these steps, I did the same thing in both. And I had to divide these 2 y values, 405 divided by 5. And then I had to take this number root. So you could either write it out this way or this way. If you like solving equations, then you might like this way better. This way we kind of got by looking at the table and reasoning through it. Okay, let's check out this next question. This next question has one extra piece that makes it a little bit trickier, and that's that we don't have one of the x values being 0. We can still totally use either method. This time I think I'm going to do the system of equations method first and then show you the other way. So y equals a times b to the x. I'm going to put in this x and y, and I'm going to put in this x and y. So I have 80 equals a times b to the negative 1. And I also have 5/4 equals a times b to the 2. There we go. So I have these two equations with a and b, and I'm going to try to find each one. It's not quite as easy as the one before because I don't have anything like this that I can just cancel out right away. Instead, what I'm going to do, maybe you can tell from what we've done so far, is that I need to divide something. So I'm going to divide these two equations. I'm going to take 80 and I'm going to divide it by 5/4. And I'm going to take this side of the equation and I'm going to divide it by this side of the equation. So 80 divided by 5/4 is 64. So I get 64 equals a divided by a cancels out. B to the negative 1 divided by b to the 2 is b to the negative 3. Remember, when we divide exponents, that means that we subtract the exponents. So when we're dividing two terms with exponents, we need to subtract negative 1 minus 2 would make negative 3. Now I need to solve this for b. And I can basically do this, it's kind of a silly way to do it, but we can do a negative 3 root of 64. You could do it in a couple of steps also, but I think this is fine. Negative 3 root of 64. I think I need to put it in parentheses. Negative 3 root 64. There we go. So if you do this in a calculator, you need to put the negative 3 in parentheses when you do this root part. Good to know. And then if I turn that into a fraction, I get 1/4. So the negative 3 root of 64 is 1/4 equals b. Okay, we found b. Now, just like we did near the beginning of the year when we do a system of equations, we need to take that value that we found for one variable and put it back in to find the a. So I'm going to do this equation. 80 equals a times b, which we now know is 1/4 to the negative 1. 1/4 to the negative 1. Negative means flip the fraction, so it's going to just turn out to be 4. So 80 equals 4a. Divide both sides by 4, and we get 20 for a. So we found b, we found a. Our equation must be y equals 20 times 1/4 to the x. And if we wanted to, we could check that in the table. So 20 times 1/4 to the x. In the table, I have -1 with 80, and I have 2 with 1.25, which is the decimal version of 5/4. Perfect. Let me also show you the way we could do it that's a little more like this. So between -1 to 2, that is 3 steps, right? -1, 0, 1, 2. 3 steps between those two. And then between 80 to get to 5/4, I needed to divide by 64, or that's the same as multiplying by 1/64. If we divide these two to find what I need to multiply by, it's 5/4 divided by 80. So to get from here to here, I need to multiply by 1/64. So I need to do 1/64 in 3 steps. That's going to be the cube root of 1/64 equals 1/4. That gives me the b. And then to find the a, I would do this same set of steps again. So depending on which one you prefer, I bet some people will prefer this way over this way. Either way works. What you need to do is find what you are multiplying by, how many steps you do, and then you're going to do some kind of root to get to the b. Okay. I know these are tricky. We'll get more practice with it. Hope that you are having a good day, and I will talk to you again soon.